guys, final presentation of the semester. So I see that a lot of our presentations took more of a comical route. We decided to take more of an epic route. So our presentation is on the adrenal hormones, epinephrine, norepinephrine. And these hormones are not only necessary for us normal humans, average citizens, but also a secret arsenal for super soldiers, such as Captain America and Iron Man, and all those dead heroes on the floor. Okay. Now, as part of our presentation, we're going to kind of go back and forth between a pseudo comic reel and information about the epinephrine and norepinephrine hormones. So, as I'm reading, you guys follow along. This is how you comics. Yeah. So, we actually managed to steal the script for Captain America Civil War. And the premise of the Civil War is as such. Captain America, the product of American bioengineering, was America's first patriotic super soldier. During World War II, there was a need to combat the rising injustices of the Nazi regime. So, this Nazi right here. Mild-mannered Steve Rogers volunteers to serve his country by being the first experimental super soldier. Jigging experiments to serum. Our brightest scientists worked diligently to enhance Rogers' endurance, strength, and fighting powers. Enough to best these killing Nazis. Right here. Okay. So, catecholamines are produced by the adrenal medulla. The adrenal gland itself is positioned on top of the kidneys, and as such, there are two adrenal glands. This is a histology of the adrenal gland, of a adrenal gland. The cortex is the outermost region and is differentiated to three distinct zones. Appropriately, the zona glomerulus, pronounce that properly, zona fasciculata, and zona reticularis. For the purposes of this presentation, I'm not going to focus so much on the cortex, but the medulla is where norepinephrine and epinephrine is produced. Now, this layer of tissue is characterized by irregularly shaped cells, but more importantly, the medulla is positioned on top of a bed of veins and blood vessels. So this allows the almost immediate uptake of epinephrine and norepinephrine. Now, Captain America, if you guys watched the movie, actually took an experimental serum that was laced with norepinephrine. Norepinephrine acts on the sympathetic nervous system as an agonist. It upregulates the sympathetic nervous system. It is secreted from chromatoprin cells, which are, of course, which are located on the medulla. It's interesting that the chromatoprin cells are actually neurons, specifically postganglionic neurons. However, they are still able to, they are actually neurons, but they don't have dendrites or axons, so they're modified neurons. They still interact with preganglionic fibers via synapses. Now, norepinephrine, it acts as a stimulatory of the systemic circulatory system, primarily as a vasoconstrictor, so it constricts veins, which leads to high blood pressure, increasing circulating free fatty acids, and increasing blood glucose level. And that's just the structure of norepinephrine. Depicted here is a schematic of catecholamine catecholamine production. Now, all catecholamines have the same conserved functional unit, which is the ketone group. So right here, the phenyl group with the two hydroxyl groups attached. Now, catecholamine production occurs via a stepwise mechanism in which the precursors have functional groups that are added. Now, and the functional groups that are added are denoted by the color red. Now, even though there are probably a couple of atoms added onto each subsequent catecholamine, the molecule itself still has a variable effect throughout the entire body. For example, dopamine is converted into norepinephrine via the addition of a hydroxyl group. So it's a simple hydration reaction, but dopamine and norepinephrine have very different functions throughout the entire body. The hypothalamic pituitary adrenal axis, or what's called HPA axis, actually coordinates the secretion of catecholamines from the medulla. And the neurons are located from the brainstem to the ventrolateral medulla oblongata, so right to the back of your head. The HPA axis actually occurs via a hormonal cascade in which the hypothalamus releases CRH, which acts on the anterior pituitary secreting ACTH, which thusly acts on the adrenal cortex, releasing cortisol, which acts on medulla to increase the catecholamine receptor enzymes, which actually play a role in upregulating the production of epinephrine and norepinephrine. And since this involves cortisol via stimulation of adrenal cortex, this is in essence a stress-mediated pathway. And this has implications on the human body, specifically via the sympathetic nervous system, because this occurs via a positive feedback mechanism. So once an individual perceives a threat or a stimuli, strong enough stimuli acts on them, they undergo the HPA cascade. Now, once epinephrine or norepinephrine is produced via this pathway, it actually causes the degradation of POMC into ACTH. Now this feeds back into the cycle, causing more epinephrine or norepinephrine to be released. So this pseudo-aneuploid pathway kind of causes and promotes the fight or flight reflex via the sympathetic nervous system. Now, comic time. You look at Captain America all pensive and stoic. So cool. So the pioneering scientists infused Rogers with an experimental drug infused with norepinephrine. The once puny Rogers now have muscles to even rival Atlas. His reflexes become 10 times that of a normal human. But how is it possible? I'll tell you how. His heart rate increased, his blood vessels constricted, his air passages widened. But best of all, his energy output became much more efficient, essentially bypassing useless metabolic pitfalls. And so, our hero, our Captain America, was born, the symbol of justice.
So as you guys know, justice has never been left unrivaled. So as soon as Tony Stark joined the Avengers, he found out what was going on with Captain America and decided that he could make it better. Stark is one of the most world-renowned weapons distributors, and so he's kind of very war-hungry. And so once injury-prone Iron Man, with this new drug, will now increase his blood clotting and blood flow capabilities, facilitating the distribution of much-needed nutrients and immunoresponses throughout his body. This will be able to allow him to better control his suit and extend his longevity in battle. The potent stimulatory effects of this drug will enhance the complete physical ardor of the subject. So what is the importance of this, you might ask? By heightening his reflexes, stamina, and all-around physical output, Stark is able to establish a deeper interface with the biosuit. This troublesome development may realize mankind's darkest fears, that unabated integration between man and machine will transcend the limitations of both. So who would be able to stop such a formidable force? If Stark Industries is capable of mass-producing this drug, then nothing, not even Captain America, is going to be able to challenge the assault of Iron Man. So even the worst is yet to come. Okay, so Iron Man's drug of choice is going to be epinephrine, which is obviously very similar to norepinephrine, but better. So it is obviously similar in structure and function. So it's also a vasoconstrictor. It increases your metabolism by enhancing glycogen lysis, so it upregulates your blood glucose levels, and increases cardiac output by vasoconstriction. It is still produced exclusively by the chromatin cells within the adrenal medulla, and is a sympathetic nervous system agonist. The thing that's more potent about epinephrine is during a release episode of these catecholamines, epinephrine is going to account for 80% of the total amount of catecholamines produced, whereas norepinephrine will only be 20. Okay, so once again, this is just the cascade of the synthesis of these catecholamines. And so norepinephrine has been hydrated into dopamine, and the only difference between norepinephrine and epinephrine is this methyl group over here. And so that methyl group might increase blood solubility just because it's a bit but it's also going to make it fit into the active site differently. So these two drugs are going to have different effects based on what type of receptor they're binding to and where the receptor is located. So the receptors that are have a higher affinity for norepinephrine are located more on the peripheral systems rather than the central. And so in the alpha receptors, it's been found that norepinephrine has a higher affinity, but in the beta receptors, epinephrine is more responsible or has a higher affinity, so it works a little bit better. So these are just obviously it's the same characteristics going on, but it just basically depends on where the receptor is in the body and which one is going to be binding to it. That's the comics. Okay. Sorry. Hold on. Okay, so self-proclaimed greatest scientist of the 21st century has revolutionized the art of war. All around the world, he's going to be praised for his intellect and scientific inquiry. But using this drug is going to come at a cost. And if he's able to make an army of biosuits, then we have a lot on our hands to be dealing with. So,
Before we play this video, how many of you guys are on Team Captain America and Team Iron Man? So Team Captain America first. Who wants norepinephrine? Good Americans. Good citizens. So 1, 2, 3. Nurse, you guys want this illegal drug?
so when Captain America discovers Stark's true intentions with this drug, this civil war is going to outbreak, and we're going to have a battle between the classic American soldier and the new bioengineered Iron Man.
So I'm gonna play this video for you guys.
It's not a spoiler of the movie, right?
No,
Nah,
no,
it's
no.
Age of Ultron, so that's
Iron Man
Yeah. This is like
you wouldn't do that.
in the comics.
It came out I think recently.
Civil
May.
War, yeah, it's
I
out.
missed it.
Iron Man blows a hole through his chest in the comics.
Alright, damn.
Shooting the guy let off. You know damn well what. Back off. Oh, I'm starting to want you to make me. Big man, suit of armor. Take that off. What are you? Genius, billionaire, playboy. I've seen the footage. The only thing you really fight for is yourself. You're not the guy to make the sacrifice play. To lay down on the wire and let the other guy crawl over you. I think I would just cut the wire. Always a way out. You know, you may not be a threat, but you better stop pretending to be a hero. A hero? Like you? You're a laboratory experiment, Rogers. Everything special about you came out of a bottle. Put on the suit. Let's go a few rounds. You're not going alone. You gonna stop me? Put on the suit. Let's find out. I'm not afraid of you, old man. Put on the suit. Put on the suit. Yeah.
So tensions are rising. Let's see how this develops.
Alright, so unfortunately this increase in physical ability is going to come at a cost.
Oh, sorry.
As you can see, the arc reactor, which is actually palladium, but we're pretending it's norepinephrine, is going to cause a lot of issues and lung toxicity in Iron Man.
Okay. Alright. Since the adrenal medulla hormones act on the sympathetic nervous system, complications with catecholamine function tends to lead with negative effects of the autonomic disorders. So technically like the heart, the muscles, etc. One such of these conditions is called pheochromocytoma. And this is just a cancer growth of the adrenal tissue, specifically the chromatographin cells. Now, this is unique in that it results in oversecretion of catecholamines, so epinephrine, norepinephrine. This is like threatening because it can place an overtaxing amount on the heart. This can cause the individual to undergo cardiac arrest, as Sierra briefly explained. And this is a cancer. On the opposite spectrum, non-chromatographin periganglioma is the neoplasm or the abnormal morphology of the growth-hormone negative glomerulus cells. And these cells are just catecholamine-dependent cells that are involved in regulation of breathing. So this goes more along the lines of the systemic circulation. And both of these cancers can actually be treated via a number of ways. These include the surgical removal, so it's pretty invasive, or embolization, so like the blocking of the blood vessels, or chemotherapy. Now, one of the major conditions associated with an overproduction of catecholamines is referred to as Burner syndrome. This is unique in that it doesn't necessarily have an effect on the sympathetic nervous system, but research has shown that Burner syndrome has been associated with antisocial disorder, Alzheimer's disease, autism, bipolar, ADHD, even mental retardation. And this is the result of a mutation in monoamine oxidase A. And this enzyme is involved in degradation of catecholamines and serotonin. When this mutation occurs, it results in an elevation of epinephrine and norepinephrine. This diffuses through the blood-brain barrier and overacts on the nerve receptors inside the brain. And a study has even shown that individuals, specifically children who have behavioral issues, tend to have low monoamine oxidase A activity, as shown here. So we can read this graph, or rather this chart, in the following way. Maltreatment has to do with those who misbehave or those who didn't misbehave. So no maltreatment, they're good kids. Maltreatment, they're bad kids. When